All right, so I'm gonna just jump right into the video. So this is basically the diagram that's in your page that kind of just summarizes all of the things that we looked at in the paper folding that we did. So we have a bunch of different things. They were the special segments. One of them is the perpendicular bisector. And I'm kind of going to go out of order and jump over here to like, what does one of those look like? And I'm going to try to draw a random triangle that doesn't look like a perfectly equilateral. I'm going to kind of draw a straight line and my vertex to be a little bit off center. And I'm going to do that for all of these just because I think it'll be more clear what the segment looks like, because sometimes in a more perfect triangle, they can almost all look the same, and that sort of defeats the purpose. But we have the perpendicular bisector, we're going to have angle bisectors, we are going to have what's called a median and an altitude. And so a perpendicular bisector was where we found the midpoint of the one side and then 90-degree kind of flew straight up. The angle bisector is where the goal is to take this angle and kind of find the halfway point and then just like shoot the line out wherever. Like the goal is just that these two angles are congruent. It doesn't necessarily say anything about where this is going to cross. A median also found the midpoint, but then just connected it straight back to a vertex. And the altitude is kind of like what we refer to as like the height of a triangle. It's from the vertex straight down to a 90. So it's just as far as like what goes here, they're just saying what features have to be happening. Other things might be like a sometimes, like it's possible, but what has to happen with the perpendicular bisector, it must use a midpoint and it must fly at a right angle. The only thing about an angle bisector is it for sure cuts at this vertex, but we don't really know. It may or may not be a right angle, may or may not cross at a midpoint. The median needed the midpoint and then we connected it to a vertex. The altitude started at the vertex and then dropped straight down to a right angle. So you'll notice none of these combinations are the exact same. We then basically said, well, what happens if you kind of turn your triangles and do that two more times so you get all three of them? Is there anything interesting? And it was interesting that all of these random things, when you do all three of them, all connected at a common point. You're like, that's weird, so weird that we're gonna give it a name. They call it point of concurrency. It just means the point where they all like run into each other. And so perpendicular bisector is called the circumcenter. The angle bisectors were called the incenter. The medians met at the centroid, and the altitudes met at the orthocenter. I know that in my class we kind of made up this really dumb sentence called crunchy peanut butter is always better, and it was like just to like something you'd remember, and it was to try to remember that the crunchy is the perpendicular bisector. So crunchy peanut butter is angle, so always better. So crunchy peanut butter is always better. Crunchy peanut butter is always better. And that just kind of help organize them. Something I also tell people is you'll notice that the word angle starts with an A. And so angle bisector and incenter are both vowels. Altitude and orthocenter are both vowels. Whereas like the P in perpendicular and the C, the M and the C are both consonants. So just like different things as you're trying to just kind of memorize who's who and what's what. You may just kind of accidentally learn them all, but just different things to look at. So some properties about the intersections. And what I basically wanted you to write in this spot was that perpendicular bisectors have that property of being in, on, and out. The same thing happens with altitudes, in, on, and out. And what we mean by that is depending on the shape of the triangle, that object can occur like physically inside. So when we say in, we mean like in this area of the triangle. When we say on the triangle, we kind of mean along the edge. And then out means like beyond that. And I'm gonna kind of just quickly sketch one example. I'm not gonna do it for all of them, but let's say the perpendicular bisector. So if I have what we would call an acute triangle, when I find the midpoint and fly out at a 90, find the midpoint, fly at a 90, midpoint 90, then that will land in the middle. When we do, let's say, a right triangle, so I'm trying to make this a perfectly right triangle, I find the midpoint and fly out, find the midpoint, fly out, find the midpoint, fly out, that intersection we're noticing is occurring physically on the edge of the triangle. And then if we do something that's much more obtuse, we find the midpoint and fly out, find the midpoint and fly out, midpoint and fly out. I actually have to end up continuing these lines somewhere else to find where that crosses. So when we're saying in, on, out, we're referring to the fact that that type of special segment will all meet somewhere unique. Whereas the other two are, I'm going to just tell you to write in. These ones always are inside the triangle no matter what the shape is. And I will point out to people that the ones that have this in, on, out are the two that do require a right angle, because when I, like, let's say I take like a median where I start at a corner and connect it to somewhere on the edge, like there's no way for those things to not like stay inside the triangle. But if I'm just going, find this random point and fly out at a 90 degree, it kind of opens up more weird opportunities, and that's sort of what I kind of remember in my head. But the number one thing I always tell people is remember, in means like inside the area space of the triangle, on the triangle means along the edge, like the ink that you drew the triangle with. Because in my head, I hear on the triangle, I also think like inside of it. And so just to be really careful when we're using that vocabulary in class. So what's going to go in the something special about each of these things, and I'm going to go ahead and talk about the perpendicular bisector circumcenter since I have it all 3 times. What that object found was the circle that if I took this center and I took the 3 corners, these would be like the radius or the radii of a circle that would perfectly like tap each of those corners. And so for this right triangle, if I were to connect to this corner, to this corner, to this corner, those are the radii of a perfect circle. And same thing here, this one going to this corner, and this corner would be the radii of that perfect circle. And so I also tell people when you're memorizing these names, I think of circumcenter kind of reminds me of circumference, and it's that outside circle that's being drawn. So what I had my students write here was just that this one is going to be equal distance to the vertices, and then I drew like a little kind of equilateral triangle circle here with the outside circle, just to remind me that this is the one that I have. Once I find that magic point, it's the point that's equally distant to each of the 3 corners, and it gives me that visual outside circle. The in center is similar. It's going to be equal distance to the sides, and the little sketch that I would draw in there is like my little triangle. When we find the center, we're looking for a circle that barely fits inside, and so it's called equal distance to the sides because this length is equal. Like it's hard to, I'm just kind of like, if I drew a random triangle on here and I just told y'all, hey, try to make a perfect circle that barely fits inside, you'll eventually like just kind of guess and check until you sort of find it. But what we're suggesting is the in center, where if you take the angle, cut in half, the angle, cut in half, the angle, cut in half, you will naturally find the center of that circle. Like that's what it's giving us. So I would, like I said, there's a little sketch of the outer circle versus the inner circle. What's special about the centroid is, now I will try to kind of sketch this like midpoint, 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 connect, connect, connect. This one has what I'm going to call the 1, 2, 3 ratio, and we'll talk about that more in math, but it's just a good thing to put in your notes. And I would say there's nothing super duper special about the orthocenter. I don't want to say like, well, why are we learning it? But just as far as like really interesting things that happen that allow us to do more interesting math, these 3 things have that, and that's really what should go down. Okay, the rest of today was just going to be mixed practice. And so if you were in class and I was here, we literally would have been like, okay, go to this page, set the timer for like 5 minutes. Which one do you think this is? And so if you're wanting to follow along, I'm going to encourage you to like pause the video so you can actually try it. You'll get more out of this if you try it and just are wrong, and then figure out why you're wrong. If you're just like following along to copy, I get the same paycheck, doesn't bother me, but it's not gonna help you on your eventual quizzes and tests. But the one thing I wanna point out is that when you're trying this, they might be showing the objects, like they might be showing the perpendicular bisectors hitting each other. So you're gonna say, ooh, that's the circumcenter. But they might, instead of showing you that, they might show you what we know about it, which what I mean by that for the circumcenter was that special point that once it was found, it had equal distances to all three of the vertices. So when you're looking at these, you might be looking at the objects that found the middle point, or you might be looking at what we know about it. And so, like I said, I'm going to tell you to pause the video. I'm going to count down from 5, and I'm going to go over them. So if you want to try this on your own, 5, 4, 3, 2, 1. Here we go. So I noticed that this one was showing me that all of these are midpoints, and they're being connected to the vertex across from it. So that is, it's made of medians, which means the answer is centroid. Here they're showing me evidence of angle bisectors, which would be the answer in center. And you might notice that if I were doing this question, when I found the angle bisector, I generally would have extended these lines like all the way so I could find them. You'll notice in their picture, they just kind of like cleaned it up. Like once they found it, they just kind of erased the rest of the extension. So things like that throw you off. I'm just pointing that out to you. This one, I see a vertex leading to a 90 degree. These are altitudes, which means this is the orthocenter. Here I have evidence of all the sides having a midpoint, evidence of the perpendicular 90 that's flying out. Again, I would usually have the rest of the lines on here, but they cleaned it up. But those are evidence of perpendicular bisectors, which is the circumcenter. This one is also median, so this one is the centroid. This one kind of throws people off at first. I don't have any evidence of midpoint, so I don't know that this is a centroid. I don't know that this is like perpendicular bisectors. I don't have evidence that these are going to hit the vertices, so I can't say these are altitudes. So this is one that if this is your first time, I would maybe expect you to get stumped on it. This one is actually going to be the in-center. And what they're showing, well, I almost feel like there needs to be more information on this one. I think this one probably should have had these ticky marks on it. I haven't looked at this file in a while. I just like pulled this up on my off period real quick on a Wednesday because we're wearing pink. But I think we're just supposed to show that because these are the radii of that inside circle that we find. And if you don't have evidence that those are all congruent, I don't think we could confidently say this. But otherwise, I think it was trying to show like the thing that we knew. But that I want to say it's a typo, but like we probably needed to make sure the ticky marks were on there because number 7 does correctly have the 3 ticky marks where these are the ones that said, once I found this point, I'm equally distant to all the 3 corners. That means I could make that outside circle. This one is that circumcenter. So they didn't show the perpendicular bisectors that found it. They just showed what we know that's special. And that's why I'm pretty sure this is intended to be the in-center. It was intended to be the inside circle that we knew. This one looks like altitudes, which is the orthocenter. Okay, and then we're gonna have a long Thanksgiving break, but when we come back, we're gonna do like a couple more days where we do this again. So hopefully as you do more, you'll get better at it. And then the last thing, it's not always, sometimes never, this is more just vocab. We're just saying, hey, this would have been the next thing I would have done in class. Like, hey, take 15, 20 minutes, probably not even 20 minutes, let's be honest, 10 minutes, read through these, write down what you think the answer is based off all the discussions we've had. You will, again, get better benefit out of this by just answering the ones you know, skipping the ones that seem confusing, and then just maybe unpausing this video and kind of looking at them. I will try to circle as I talk about them, so if you just want to like fast forward and see when I talk about a certain one, you can do that, so it kind of saves your time. But again, if you want to do this, start now, and then I will pause the video. Okay. So the point of concurrency, so when all the medians meet, that's called the centroid. Number 2 says the blank is the perpendicular segment from a vertex to the opposite side of the triangle. So from a vertex making perpendicular, we are talking about the object altitude. And so notice they're talking about the segment. They're not talking about when all 3 of them connect, that makes an orthocenter. So just kind of that's something to be mindful of. Are they talking about one of the little things called the altitude, or are they talking about when all of the altitudes intersect? Number 3 says the centroid lies in, on, or out of an obtuse triangle. So we need to know that centroid from our notes page is always inside, no matter what, always inside. I will point out, if I didn't mention this before, but when we talk about one like the circumcenter, that can be in, on, or out. The in is always for the acutes, the on is for rights, and the outside is for the obtuse. So when they say obtuse triangle, it is outside if it's one of the ones that shows up different places. If it's a type of triangle shape or that centroid where it's always inside, then they're trying to confuse you and think, ooh, obtuse is outside. Be like, just kidding. This one, they're all three on the inside. Okay, the blank is the intersection of the angle bisectors. So when all the angle bisectors meet, that one is called the in-center. 6, the blank is a line, right, or segment or plane that is perpendicular to a segment at its midpoint. So we're mostly talking about this special piece where we're using a midpoint and perpendicular. That is that perpendicular bisector. And again, just like altitude, they were asking about one of the objects, not like what it's called when they all meet. Number 7, the blank is the intersection of altitudes. So when all the altitudes meet, that's called the orthocenter. 8, the blank is a segment from a vertex to a midpoint. So the segment when I connect a corner to a midpoint is a median. Again, all the medians intersect at a centroid, but one of them is a median. The orthocenter. So the orthocenter uses altitudes. So anything that uses the right angle, so the perpendicular bisector and the altitude, those are the ones that have that in, on, out feature. And so for a right triangle, this one is going to be on. But again, if I talk about the centroid, I don't care what this says, the answer is always inside. Or the in-center is always inside. Okay, number 10 says the blank is the intersection of the perpendicular bisectors. That's just vocabulary. Circumcenter. And again, this is where that crunchy peanut butter is always better helps me. I'm like, crunchy peanut butter. Like it just reminds me, okay, that's that circumcenter one. Number 11 says the blank is equidistant to the vertices. So this is the one that says once I find it, I'm the point that's equal to the 3 corners. That is the outside circle. That is also the circumcenter. And I always just remember circumference of a circle. So I think of this outside circle. And then the one below it, number 12, it's the in-center when the, I almost drew a circle. Oh, I did draw a circle. Where what we find is equal to the 3 sides, it creates an inside circle in there. So the in-center has the inside circle, the circumcenter has the circumference outside circle. And again, I'm just trying to tell you things that I say to myself to remember all of these things. 13 says if a point is on the blank, it is equal to the endpoints of a segment. So if I was to pick one that's just kind of worded weird, it's this one. I don't know that I care a whole lot about this, but the point is on like which of the special segments if it is equal distance to the endpoints of a segment. So I'm just kind of draw what I mean. Like here's a random segment, here are the endpoints of that segment. So if I'm a point that's, let's say, not on here, because if I'm on here, I would be called the midpoint. Okay, I'm a midpoint if I'm equal distance to the endpoints of a segment. Like you might think midpoint, but I think what they're referring to is what if that point's not the midpoint? What if this point instead is like more floating in outer space? Because if I try to put that point, let's say like here, then when I connect it to you and to you, these are not going to be the same distance. So they're like, well, if I am the same distance, then where is this point located? Is it located on the angle bisector? Is it located on the blank, blank, blank? And so this one is always going to be considered on the perpendicular bisector. It's kind of like if I find the midpoint, if I'm not the midpoint, but I fly out at a 90 degree, no matter where I'm at, this point will always be the same distance to those 2 sides. And that kind of goes with the math from the other day. So the answer here was perpendicular bisector, but I'm just gonna flat out tell you, I'm not super sad if 13 is confusing to you and you just wanna like pretend it wasn't on there. I think the rest of them is really the vocab we're trying to hammer in. Lastly, the in-center is located in, on, or out of a right triangle. Remember, the in-center is the inside circle. There's no way for that to be anything but inside. All right, and like I said, you're gonna forget everything over Thanksgiving break anyway, but when we come back, we're gonna have a page to kind of refocus on like the chart that we just did. We'll kind of re-hit the highlights, but this is a great kind of thing like before a quiz or test to open up on Canvas, the blank one, and kind of read through and kind of quiz yourself. Like, okay, go to a random one, what's the answer? Go to a random one, what's the answer? Just to make sure that you can kind of keep all the vocab clear. Okay, that's it. Video's under 20 minutes, cha-ching. Hopefully you watch this on fast forward, so you got that a lot quicker. Anyways, have a great break.